Welcome back to Global Education Zone. My name is Anthony Nathaniel, and today I'll give you an introduction into organic chemistry. Organic chemistry is a very important part of chemistry, and we're talking about what organic chemistry is. We're talking about what organic chemistry is. We're talking about organic families. We're talking about nature of nature of compounds. We'll talk about functional groups. Talk about homologues. We'll talk about much more. So now let's kick right in. Now, organic chemistry. In the early days, organic was a word that was associated with living things. So most early scientists thought that anything organic can only be synthesized by living things, or basically by a vital force. But nowadays we have understood that organic chemistry is about compounds that can not only be made by the vital force, but can be made by every other system. They are not like normal compounds, but they are compounds of carbon. So organic chemistry is the chemistry of organic compounds, and organic compounds are the compounds of carbon. Those compounds of carbon, they possess carbon as their major element in addition to other substituents. So organic compounds, they must contain carbon. That's the property of organic compounds. They must contain carbon. Example of this is when it's something like this, CH4. This is formula for making, right? This is an organic compound. It contains carbon and hydrogen. So hydrogen is just like a broader element, but carbon is the main element in organic chemistry. Now there are some carbon containing compounds that we choose to ignore because they are too common and they are not very good examples of organic compounds. Example of that is CO2, carbon dioxide. So CO2 is also a carbon compound, but we don't really emphasize it when we study organic chemistry because it's too common. So there are other compounds too that are common, but organic compounds, they are basically classified into alkanes, and alkynes. Alkanes have the general molecular formula of CnH2n plus 2. So all these alkanes, they are hydrocarbons. These are alkane family. Alkane. Then CnH2n is the alkene family. Then CnH2n minus 2 is the alkyne family. Then lastly, we also have benzene. Or we call them aryl. C6 is H6. So we have benzene and its substituent. So these four, they are the principal organic compounds. These three are called aliphatic compounds, and this benzene is called an aromatic compound. We also have alicyclic compounds. They are like cyclic compounds that are not benzene. Benzene is the major cyclic compound. It's an aromatic compound because aromatic compounds tend to have a sweet smell. Something like your onions, your aromatic compounds, they are just like your flavors, the fruity flavors, your food flavors. So aromatic compounds, they smell nice like benzene and benzene substituents. We'll talk about that in some time later. But let's focus on alkanes, alkynes, and then the basic structure of benzene. So alkanes have CnH2n plus 2, right? So alkanes have what they call members, and those members are of the alkane family. That alkane family is called a homologous series. This CnH2n plus 2 is properties of the homologous series of the alkane. So this N can be 1, 2, 3, 4, 5, and so on and so forth for the alkane family. So if we start from N is constant, we have Cn. Cn is what? Cn is 1, I mean C1. So let's leave the 1, C, then H2n plus 2. 2n is what? H. 2 times 1 is 2 times 1. 2 times 1 plus 2. That's CH. 2 times 1 is 2. 2 plus 2, that's 4. CH4. So this is methane. Now this methane, no matter what the name of the alkane family is, they always end with "ane" because this is alkane family, this is alkene family, and this is alkyne family. So alkane family always starts with "ane", methane, ethane, propane. Now that ethane is for 2. Let's put n is equal to 2. C2 H, so 2 open brackets, n is what? 2, abi? 2 plus 2. That's C2 H. 2 plus 2 times 2 is 4, right? 4 plus 2 is 6. That's C2H6. That's ethane. Can also talk about propane. When we put n is equal to 3, C3 H 3 open brackets times 2. So open 2 open brackets 3. Sorry. Plus 2. That's C2 C3 H 2 times 3 is what? 6. 6 plus 2 is what? 8. So that's C3H8. That's a thing. If you keep putting that n is 2, n is 3, n is 4, n is 5, you keep getting methane, ethane. This is propane. When n is 3, we have propane. When n is 4, we have heptane. Sorry, when n is 4, we have butane. When we have n is 5, we have pentane. When n is 6, we have hexane. When n is 7, we have heptane. When n is 8, we have octane. When n is 9, we have nonane. When n is 10, we have decane, and so on and so forth. So it doesn't end. It comes out. It comes on and on. They are compounds that are very complex. We have when n is 20, n is 10, n is 50. Those are also types of petroleum products, because crude oil is basically a mixture of hydrocarbons. So this alkane is a type of hydrocarbon, and hydrocarbon is a subtopic under organic chemistry. We have under organic chemistry, we have chemical compounds, and under that we have hydrocarbon. Hydrocarbons are basically compounds that contain only carbon and hydrogen. So hydrocarbons, they contain what? Carbon and hydrogen. But that carbon and hydrogen, you can mix them in different proportions. So when they are showing a gradual similarity in proportion, that is called, it forms an homologous series. Now you can notice that this CH4, C2H6, C3H8, they are all C and H. They both contain carbon and hydrogen, but the number of carbon and hydrogen atoms differ, but they all have the same general molecular formula. That's why we call them C and H2N plus 2, the alkane family. Let's move to the alkane family. The alkane family is C and H2N. So that means for the alkane family, there's no n is equal to 1. So we start from n is equal to 2, n is equal to 2, 3, 4, and so on and so forth. But n cannot be 1. So we start from 18. So when n is equal to 2, we can say C and n is 2, right? N is 2, H 2n, 2 times 2. That's what? C2 H4. That's 18. When n is 3, we have C3 H 2 times what? 3. That's C3 H 3 times 2 is 6. C3H, that's propane. And so on and so forth. When n is 4, we have butane. So they all end with in. That's the alkene family. For the alkane family, they all end with in alkene family. For the alkyne family, they only end with ine. Ethyne, propyne, butane, so on and so forth. So we'll talk about the ethyne family now. The formation of the ethyne family. So this is organic chemistry, and we're still talking about hydrocarbons, right? Now this ethyne family under hydrocarbons. Ethyne family are characterized by Cn H2n minus 2. Now that's the general molecular formula. So and this, as I mentioned earlier, they formed homologous series, right? Now and n will start from 2, n will start from 3, n will start from 4, 5. So now we'll talk about alkynes, right? Now let's look at the homologous series of alkynes. Now we'll start from n is equal to 2. C and n is 2, right? C2 H2n minus 2, 2 what? N is what? 2 times 2, then minus 2. That will C2, 2 times 2 is what? 2H, 4 minus 2, that's 2. So this is the simplest alkyne, and it's called ethyne. Ethyne. UTME. So it's the first member of the alkyne homologous series. Now all these ones that have general molecular formulas, they form homologous series. We have alkane homologous series, alkene homologous series, alkyne homologous series. We have benzene, and all these homologous series, they are also known as organic families, you understand? And they have their own characteristic functional group, which we'll be talking about in a subsequent time. We'll talk about that later. Now we'll talk about, if we put any substitute, we have C3H 2 times what? 3 minus 2, because it's H2N, N is 3, right? 2 times 3, then minus 2, that's C3H. 2 times 3 is 6, 6 minus 2, that's 4, C3H4. And that's the second member of the alkyne homologous series, and that's called what? Propyne. Now call it PROPYNE, and so on and so forth. So propyne is the second member of the alkyne homologous series. Now finally, on top the topic of alkane, the last one I'm talking about is benzene family. So benzene families, they have the general formula of C6H6, but any of those hydrogen atoms can be substituted. Now some time ago, I'll tell you a story. A scientist known as Kekule, he was the first person to find out the property of benzene and the structure, that's chemical structure of benzene, and he discovered it when he was dreaming. So in some video, I was talking about the fact that science is all about your ability to observe, to be whether conscious or unconscious. Once you observe something and you are able to discover something, science is all about discovery. So the person who discovered the structure of benzene was Kekule, and he discovered it in a dream, something that you won't even believe. So now benzene, from Kekule's discovery, benzene from Kekule's discovery has a formula of C6H6, and those atoms are formed in an hexagonal ring. So this is called a hexagon. Hexagon has 6 sides. So a benzene ring has alternation of double bond. So in the subsequent we will talk about bonds, but these double bonds are alternate. So there was bond in this carbon, this is a 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 carbon, and this is a carbon. So now in another video I'll be talking about the bonds, how bonds are formed. But today we'll just go about an overview of introduction into organic chemistry. Now this is the basic structure of a benzene ring, and these bonds are double bonds. So thank you for listening, and in another video talk about organic chemistry in detail. Thank you.